All right. Next, we got to talk about what's in the atmosphere. College Board loves this question. I guarantee you it's on the AP test all the time. And I'm sorry, I was a little bit lazy and I didn't subscript the numbers. So you'll notice where it says N2, that should be an N with like a little 2 down below. That's 2 nitrogen atoms and nitrogen gas. So the College Board loves these questions. They always ask them. So really quickly, the most common gases, you probably got this out of your book: nitrogen, oxygen, argon, carbon dioxide, and nitrous oxide. If you do the math, though, look at this. Let me see if I can't get my pointer back. Look at this. 78% of our atmosphere is nitrogen and 21 is oxygen. That's the stuff that we breathe. This is what nitrogen fixers use to make nitrogen compounds that are important for life. So 78 plus 21, that's already 99%. And then argon, an inert gas that doesn't really interact with anything in our atmosphere, in our part of the atmosphere, that's the other 0.9%. So all the other gases in the atmosphere, all the air pollution, all the naturally existing water vapor, nitrous oxide, CO2, methane, ozone, all the other stuff, the sulfur oxides, the nitrogen oxides, all that other stuff is like less than 0.1% of the atmosphere. And the manipulations we're talking about of the atmosphere are a small percentage of a gas that's a small percentage of that. One thing that I need to stress is that most of the atmosphere is really not important for climate change because most gases aren't greenhouse gases. Nitrogen, oxygen, argon, that's 99.9% of the atmosphere. Nothing to do with climate change. Nothing to, you can ignore those. They'll never come back. I don't think those will ever come up in this class again. But there's a few gases that matter, and we're going to talk about greenhouse gases more later in this unit. But really quickly, I want to explain what we mean by greenhouse gases. Most gases are not greenhouse gases because they're stable. So oxygen 2, it's 2 oxygen atoms bonded together. And no matter what happens, oxygen 2 is just 2 oxygens. You can heat it up, you can cool it down, and it's just 2 oxygen atoms. Most bonds are really stable, so they don't really change. If you take 2 nitrogens, they're just stuck. And you heat it up, you cool it down, doesn't matter. But there's a few gases that are interesting. I want to talk about this. Like H2O, you've probably seen like the Mickey Mouse logo, right? Where it's like 2 hydrogens stuck on an oxygen, right? You've seen that, the Mickey Mouse logo for water. What's interesting is some things like H2O, when you heat them up, those bonds destabilize a little bit. And after a while, they will restabilize. And those are the greenhouse gases, because heat energy becomes kinetic energy. And then when those bonds restabilize, they re-emit that heat. Greenhouse gases absorb heat, translate that into kinetic activity, and then when those bonds restabilize, that heat is radiated away. There's a lot of chemistry here that we don't have time for. So they're called modes for the different types of vibration. And if we were in the classroom, I would do some dorky dance. Let me see if I can figure this out. There's this mode. There's this mode. You know, different types of vibration. There's like this one, and there's this kind, and there's like one that's sort of like this. Anyway, different gases have a different mode of vibration. You probably don't need to know that. But what you do need to know is that the ability to trap heat, that energy goes somewhere, and then they restabilize and give off the heat. The ability to trap and re-release heat, that's what makes them greenhouse gases. And we're going to talk about them more later. You'll need to know more than I'm telling you now. But I just want to be clear that what makes them greenhouse gases is also really old science. This goes back to roughly Fourier. We've known since the middle 1800s that some gases capture heat better than others. I had a demo that I've been building for about 15 years, which is a collection of different gases, and you put them out in the sun and you come back, and after 20 minutes, each of them has a different temperature based on which gas is inside. Greenhouse gases. You're supposed to know all the gases in the atmosphere, and you're supposed to know that a few of them are special. They absorb and radiate heat. I want to stop this video.